but it is in the context of campus. So I'll use words like metropolitan area, and like I said, maybe these are across an entire city with dark fiber, okay, L2 circuits and these things. But at some point, you actually have a proper WAN, that goes off to like the East Coast, right? And that's a router discussion. Okay, that's all good. Then we have terms like collapsed core, and I have more of these, by the way. Extended access, okay? These are variations. The thing I want you to remember, they are variations, and they are only variations. So we're going back to fundamentals. Why did I build an access layer? What is the goal of the access layer? Maybe I need a couple of hops to make that work. Same thing with a core, right? Why do I build a core? Well, maybe based on scale, I need to break this core into a couple layers. Or in fact, it's small enough that I can justify collapsing those layers, okay? That's the part I want you to remember. When do I grow and when can I collapse, okay? This is a busy slide. Like I said, I'm not going to try to read to you. I did throw up some catalyst switches to give you kind of a reference model. By the way, there are entire sessions on the catalyst switches. So this session's not trying to teach you the box, but they are sized for these layers, right? So we build access layer switches. We build distribution and core switches, right? Now, the piece I do want you to remember again is there's always 3 logical layers: core, distribution, access, okay? And again, we're going to talk through each one of these so you don't have to memorize this. The part from this slide I want you to remember is the little guy in the corner. I don't know if everybody noticed the little guy there. And what he's going to tell you is, look, remember the boss is trying to get you to save money, right? He says, we have this much budget this quarter, and I need to replace that old Catalyst 6000. But you know what? Don't buy the expensive one. That's what he's going to tell you. I guarantee. Anybody had that conversation with their boss? Okay. Who here still has Catalyst 6000s? Okay. 4500s? Same set, folks? Okay. You should go to the Cat 9K session. Okay. When the boss comes to you, he's going to say, hey, we have an opportunity here. Let's collapse some layers, right? And maybe that is the right choice. All I'm trying to do is make you have that conversation with the boss. Does it make sense to collapse this layer, or do we need to keep them separated? Hey, maybe we can even buy a cheaper box, but break them into more layers, right? And what he's saying is, if you do collapse, don't go cheap. It says, buy the best box, but I mean, don't go cheap if you're collapsing layers, okay? Because it has to perform the task of all those layers. Modular versus fixed. Again, I'm not directly trying to tell you a specific box to buy. This is mostly philosophical in nature. Just like it sounds, modular is about the box. Stick the rack in. I was kind of setting you up for this question when I asked who had Cat 6Ks and Cat 4500s. Your company has bought into this philosophy, right? The philosophy is stick the chassis into a rack and then I can change it, right? At the same time, it means I have to manage all these moving pieces, and maybe the guy stuck the module in sideways. I don't know, right? We've had a few of those, right? And then on the flip side is fixed. Everything is self-contained, CPU, memory, everything's in the box, ready to go, right? I don't have to do anything. Having said that, what if you do need to change your fiber optics, right? Remember I talked about the cabling, the next slide's cabling, by the way. I talked about the cabling in the wall. The boss is saying, we need to boost our bandwidth, but I am not going to give you any additional money for your box. Go ahead and figure that out now. So they're just natural pros and cons, natural counterpoints to one another. Modular is more flexible, but it has moving parts, and it can be complex in its own way. Fixed is very simple, straightforward, but it's rip and replace. Okay? You need to change anything in 5 years, rip the whole thing out and start over. Okay? Cabling. So Again, I'm not going to try and read everything to you. The quality of the cable. The thing I want you to remember is the quality of the cable. Okay. There's a whole set of these. You'll hear category 5, 6, 7. There's actually category 8, category 9, OM3, OM4, OM5, and there's lower categories also. By the way, anyone have like category 3 cabling? There's a couple hands. I see you. I see you. It's okay. Just they're not very long cables, right? So the quality, of course, controls the signal integrity. How good is the signal? How far can this cable go? How fast can this cable go? Right? On the copper side, we also have this multi-gigabit Ethernet. Sounds fancy, but it is up to 10 G base T, 10 gigabits of copper, and it will negotiate the speed based on the quality of the cable. Right? That's, again, the thing I want you to remember is the quality of the cable. It's going to set your distance and it's going to set your speed. Then on the fiber side, you have SFP, or small form factor base, and you have QSFP. Anybody know what QSFP means, like the acronym? You folks? Okay. And only like 4 or 5 people raised their hand. It stands for quad SFP. So somebody got the smart idea, hey, why don't I take 4 SFP fiber signals and stuff them together, and voila, we get 40 gigabit Ethernet. So it's funny how these things evolve. Now what you'll see in this QSFP is there are lots of little tiny fiber pairs inside of the connector. Another name for it is MTP. It started as a trunking cable. Sounds weird, but if you've done wiring closets, I need to bring all these wires from the wall into a wiring closet, and then I want, like on a patch panel, to get from this patch panel to the other. I would just use this cable that had a bunch of little fibers inside of it. And somebody said, hey, I could use that as a data cable. And now MTP is the de facto standard for high-speed Ethernet. Okay. Single mode, multi-mode. Multi-mode is really about, you can see, I tried to draw a picture. It's kind of funky in such a small thing. I'm not sure about you guys back there. I hope you can see it. But it's a very simple light wave, not complex. So the whole point is it's going to be short distance. Okay. Whereas single mode is very complex light waves. The lasers are much more powerful, right? Like a laser on here, so they can get much greater distance. Okay. You probably can see along the bottom. I talked about 10 gig copper. We are now doing 50 gig, 50 SFP, and we are doing 400 gig QSFP. It's selling it right now. Like, I'm not making some BS up. In fact, there's more stuff coming. But as of right now, we are already doing 50 gig SFP, 400 gig QSFP. And what I want to leave you with is I keep telling the story about the fiber in the wall, and the boss is telling you to upgrade. Boss, if I buy the box that has these 50 gig SFP ports, I can use the exact same LC fiber that's in the wall right now, and I can give you 50 gigabit Ethernet. Okay? But if you don't, if you're cheap, sorry. Okay, I'm not going to belabor these particular slides. This is meant to be one of those like, wow, that's a lot of crap that I have to think about. Each layer, it goes back to the original point. Each layer has a job. Okay, he's going to run a certain number of protocols. He has to have a certain number of address entries that he's going to share with his neighbors and so on. Okay, and think about each layer. And remember, I said about collapsing. Like, maybe the box you want to buy is capable of these core protocols, but you forgot about distribution. So when you collapse him, he doesn't have that distribution feature, or vice versa. Maybe it's built for distribution layer, and they didn't add that complex core feature. You didn't know, and now, sorry, that collapsed box doesn't actually do what it's supposed to. Okay. Same thing for multicast. Anyone here like a multicast person, or their company does multicast? Fair amount. Okay. Same rules apply, particularly things like multicast VPN, MSDP, these kind of things. Okay? And I consider myself a multicast person. So I put in this slide just because I'm a multicast guy. It is not like an extra feature. It is the equivalent of unicast. It is an architectural level decision-making process. And you have core features, distribution, and an access layer. Okay? The other thing, I'm glad I paused myself. One thing to remember in here, and I sort of talked about it in that big topology slide, but I didn't, I think, make a good point, is the separation. There's a dotted line right through the middle of that distribution layer box. And I remember I was saying it was red up above and then it was blue down below. Layer 3 routing, right? And layer 2 switching, particularly like a particular VLAN. I'm going to talk about some of these things in a minute. It has to go to a layer 3 gateway, just like your laptop. You type in, who's the layer 3 gateway? It is that distribution layer box. And so again, like when I talk about collapsing things, doing MAC address learning, ARP entries, these become critical for that box. And the distribution layer is the often forgotten middle guy. It is actually one of the most important boxes in the network. Okay, having said that, again, I'm here to sell boxes. This is not the session on Cat9K, it's just to give you a flash. We just started shipping the X series. Anyone have the Catalyst 9000 X series? Okay. So it is really just a new set of switches with a new set of ASICs. I actually have a session later in the week where I'll be teaching ASICs and operating systems. Anyone going to my other session? Curious? No? Okay, well, tough luck for you. Anyway, it's a newer set of ASICs, but if you look in the middle, the reason I actually added the slide was the common ASIC and common operating system. And in the old days, all the people that raised their hands and had Catalyst 6000, Catalyst 4000, you could see the color of the box was different, the whole thing, the operating system was different, ASICs were very different. The important thing about Cat9K, the thing I want you to remember, including this new X series, is a common architecture, ASIC architecture, and common operating system architecture, okay? So campus core. Now I'll start off, each one says baseline, as in like the generic campus, okay? And then I'm gonna talk about variations. Again, the thing I'm trying to like really drive home for you guys is fundamentals first, variations second. So the core is the third tier, the top of the pyramid. And in its traditional role, it's just layer 3 routing. It is a basic interconnect. Its main job is to get you from one distribution layer, over to another distribution layer, depending on how the access layer network is set up. And I'll talk about distribution just after this. And you see it tends to be traditional routing protocols, okay? Your OSPF, EIGRP, ISIS, etc. Okay? And for that reason, another thing, these slides tend to repeat or have a similar format. That's on purpose, right? Because I want you guys just to immediately understand what this slide is trying to tell you, okay? And then, like I said, that awful yellow, I know it's awful, that's on purpose. Those are the kind of things like, if somebody says, what is it about a basic campus core? Here's the 2 or 3 things I'm gonna tell you, okay?